Hi everybody, can you hear me? Good afternoon.
Good afternoon.
Hey. I hope you're all doing well. Today,
Good afternoon, sir.
Yes.
Today we'll be doing practice, and this practice is, I will have problems mostly related to trees. So we have covered good amount of theory in the previous classes, starting from arrays, right? We looked at different kinds of arrays, for example, linked lists and static and dynamic arrays, basically. And then we also looked at stacks and queues. And then we looked at trees, and we are spending quite some time at trees. We looked at general, recursion was a part of stacks. We looked at different kinds of trees like binary trees and traversals, etc. We looked at binary search tree in quite some detail, the properties of BSD, and how can we traverse it. And then in the last class, we looked at different types of representations of a tree, not just using the node and the children representation, but also there could be parent pointer representation, etc. And using linked lists, we can represent the trees, etc. We looked at several implementations of the tree, and given any implementation, so the basic principle is this: you are given an abstract data type or a data structure, basically, where you have some object, let's say the tree object, and it has got various functions and some variables in it. And using these functions, how can you implement different algorithms or different functions to do something more interesting or more practical. So, okay, there are some questions in chat window. Okay, you're asking for extension. I have no problem in giving extension until Sunday evening. Yeah, no problem. Take extension, but do a good job. If you, okay, so the main purpose of this course is to take out from you any fear of coding. So take the exercises or the assignments for your practice, and if you have any questions, feel free to ask the TAs and feel free to ask me also in the class. If you think some topics are not very clear or you need some more practice on some topics, do let me know. I'll be happy to spend more time on those. In this course, I am not focusing on a lot of concepts, means not focusing on a lot of coverage. Like, I don't want to cover so many things, but whatever little we cover or whatever concepts we cover, they're all essential concepts like trees and graphs and heaps, we will see. But do them very solidly and learn the programming very solidly so that you can apply it to any domain in your research. So what I feel is that the basics and the if you are able to develop that intuition or that problem solving ability, then given you can very easily expand your knowledge to new data structures or new types of ADTs. So, okay, so let's start, and feel free to ask as many questions as you wish. So let's start with one question. This question is, so given a BSD, you have to check whether this BSD is valid or not, right? What does that mean? That means that, okay, so what is the property of a binary search tree? Yes, who would like to say?
Sir, invariant property that the left node value should be less than the right node.
Yes, the BSD invariant. BSD invariant says that all the nodes in the left subtree should be, so let's say we have a tree here. Oops, why is it not? Sorry, there is some problem with the pen. I'm fixing it. Oh, still it is not there. Yeah. So it means every left subtree should have all the nodes whose values are smaller than this node, and every right, the rights in the right subtree, all the values should be larger than this node. That's it. And this property should be valid for all the subtrees also. If I take this node, the left nodes or the left subtree should have all the nodes whose values are smaller than this, and the right subtree should have larger than this. In this case, there is no right subtree, so no problem. Like that property, this is called the BSD invariant. Now, if I give you some general tree, you have to, if I give you some general tree, you have to find out whether it is BSD invariant or not. Your answer should be just yes or no. Okay, let me put the question for you. So I will do everything on the side. I'll try to do everything here so that you can. So this is first you import the node from binary tree library because we want to print it. That's the only reason, no other reason. Now I will define a class solution. And in this solution, I will define a function called isValidBsd. That's it. So I give the node, the root node as the input, and then you have to tell me whether this is a BSD, a valid BSD or not. And the answer should be just true or false. So what is the algorithm you would like to try here?
Sir, Inorder Traversal of a BSD gives a list in ascending or descending order. So can we use this property?
Yes, definitely. Now also think about how can you make it efficient in terms of runtime, in terms of memory requirements, etc. So I think what you suggested that we can use Inorder Traversal, right?
Yes, sir.
So you said we can use Inorder Traversal. And this should give me an ordered list. Yeah, that's very good. It's, I think, computationally, it is very efficient. What is the computational complexity of this? Oh. Yes?
N.
ON. Yes.
Number of nodes.
Very good. So computational complexity will be ON. So that's very good. Now, what are the memory requirements? If you can minimize that also. How much memory will be required if I print the whole list? ON, right? You will need to save all the numbers.
Yes, sir.
And then, okay, after saving them, you will be doing a check on whether they are sorted or not. So whether they are, so sort check or check sorting. How much is the complexity of checking the sorting thing? Again, ON.
N.
Right. So overall, the time complexity is on and memory requirement also is of the order of on. Okay, can you make it more efficient in some way?
Sir, can we use width first search? Because if somewhere it like if we are going level by level, and if there is an exception in any of the level, then the program will automatically stop there. So
yeah, you can do that way. Yes, but you are saying instead of in-order traversal, you will do level order traversal. Is that what you are saying?
yes, sir. Like the array is not required, but we will go level by level. So if at some level, if an exception is seen, then the program will stop right there.
But you mean to say level order traversal?
Yes, sir.
But with level order traversal, how will you check whether it is BSD or not? BSD invariant or not? So I think in-order traversal is, I think, efficient enough. No need to do level order traversal, but just that you have to now tell me the algorithm, which is not just efficient in runtime, but also in terms of memory. Do you need to store all the values in memory and then check the sorting? Can you do it on the fly?
So we can use recursion.
Yes. In-order traversal anyways needs recursion. That's true.
Inside that recursion loop only we can put some
Yes,
condition.
sir. We can
Yes.
put a condition that if node dot left is less than node, so it will return true, and if it fails, similar condition for node dot right.
Yeah. Yes. Okay. Tell me the algorithm.
So
Okay.
first,
For your ease, I can mention what is the in-order traversal. So the function in order looks like this. In order of a node, it is simply, okay, let's say define. You will do in order of the left child, node dot left, and then you do the whatever you want to do, the operation on the, I'm just writing print, but it could be any operation. Print node dot value, and then you do in order of node dot right. This is just for your reference that this is the, and if node is none, then you return. If not node means, I think it means if node is none. If not node, then return. This is not returning anything, but just printing the values. But you can modify this algorithm. Okay, now let's do, how will you do the problem now? Yes.
Sir, this function will give us the list of the in-order traversal, this print function. So I mean, will we have this sorted list by this in-order function?
Will we have the sorted list in the in-order function? I mean, understand, what is it?
I mean, by using in-order traversal, we will have the list in. We will have the sorted list. Then we will run, I mean, a loop and find if it is sorted or not.
Yes, that is the method which you suggested earlier. But I'm saying that it may not be memory efficient because you have to save the entire array, and then you will be checking whether it is sorted or not.
Okay,
right?
okay.
Instead, if you can find little bit, if you can make it a little more efficient.
Okay, that I mean, if we can find it in runtime.
Yeah. So okay, let's start
Oh.
from here. Inorder
So we
Traversal
can
is very simple. Just a moment. Inorder Traversal is very simple. Now, finally, okay, you will be saving a. You will saving a what do you say? An array, right? So you will define some array, which will be kind of shared by all instance, right? So I don't define array inside because I want this to be kind of global variable, right? So here you will just say, instead of saying print, you will say append array dot, let me call array as something, some a equal to empty. Now you say a dot append, right? Just appending this. So this is the Inorder Traversal which you generally use. Okay, then for checking sorting, how will you do, how do you check sorting? Let's say an array is given to you. Define check sort. Let's say an array A is given to you. How do you define? The output should be a Boolean, true or false. How do you check the sorting? Yes.
Checking current value to value.
Yes, checking current value means
Like comparing current value with next value.
Comparing current value with next value. Okay, so I will define a for loop, right?
Yeah.
For an entry, some A in A, right? Then what do you do? If A is, so actually this should only return true when it is sorted and not true when it is not sorted. Sorted means basically in the ascending order, right? Because BST should be in the ascending order. So if A is, so let's define some global variable which is, let's say, largest. Largest equal to, let's say, first it will be minus infinity. I can use my either np dot minus infinity or math dot minus infinity. So first the largest is minus infinity. If A is less than largest, right? If A is less than largest, then what will happen? What will happen? Largest is basically the previous value, right? You want for sorting, this is the previous value. If A is less than largest, what will happen? It will return false. Right? Are you with me? And if A is greater than largest, actually in BSD, let us say we don't allow repetitions. Okay. In general, the repetitions are not allowed. So if we don't allow repetitions, then even if it is equal to largest, then also it will be giving an error. So less than equal to largest. Then also it will give an error because I don't want values to be repeated also. Now, if A is greater than largest, then what will happen? Yes?
A equal largest and return true.
A equal, and the A is assigned the, no, A is largest, largest is A, right? I update the largest. The global variable is updated. And then return true. Okay. Is that correct? Is that correct? This sorting is ascending order basically. Is that correct?
It has to return true after the whole loop is over.
Yes, sir. So
Yes.
it will actually go out of the loop.
Yes, very good. So basically, it can return the false immediately, because even if one condition is violated, then the whole thing becomes a false. But the true is not verified until you verify all the entries, right? So this return true should be after your loop is over. Do you agree with this?
Yes, sir.
Okay. So we have written now the algorithms. Now we have the in-order algorithm, and we also have check sort algorithm. Now, can you in some way combine the two to make it efficient? Like instead of doing in order and then doing check sort, this is correct. Like if you do in order first and get the array A, and then you do check sort, it will well tell you the answer. That's also fine. But can you make it more efficient by merging the two somehow, so that you don't have to store the A, so that your memory requirement will not be of order n, but maybe of order two, basically constant order one. Is that possible?
Implementing this check sort after each subtree traversal, in-order traversal.
Where do I insert this part? In which line?
Sir, we can put the initial condition starting. That is, if node dot left is greater than node, so it will return 0. And in the next line, if node dot right is less than, so these two conditions will false, so it will return 0. And in third line, we can use recursion, in which we call node dot left and node dot right again and again.
So you're saying if node dot left is less than node dot value, basically node dot left dot value is less than node dot value, right?
Sir, is greater than. If this condition becomes is greater than.
Greater than equal to, okay.
So it
Then
will become false, so it will return 0.
return false basically.
Yes, sir, return false.
And then
If next line, if node dot right dot val is less than node dot value,
is less than or equal to node dot value,
so it will return false.
it will again return false. Okay, then
Sir, in next we can use recursion and call the function using node dot left and node dot right. So if it's false at any step, it will return false. Otherwise, it will return true.
okay, just a minute.
At the,
What should I write here? What should I write here?
sir, the function name,
Okay,
let's say BST.
valid BST
Yes, sir.
and some node. Okay, then this is again check valid BST of
Sir, node dot left.
okay, and then again for node dot right, right?
Yes, sir. And then after it, return 1. If any of this condition fails, then it will automatically return false. Otherwise, return true.
Okay. Okay. In this algorithm, is there any mistake? Let's consider this example code 5, 3, 6, 7, 6, 9. Let me make it 4. Is this a BST?
No.
And if this algorithm runs over it, what will it say? Is it a BST? If this algorithm will return true or false?
It will return true, sir, because it is not taking parent node in consideration.
Yeah, this is only checking this with the left node and this with the right node. It does not check this with the right dot left or any of the children nodes. This algorithm will not work for this case. It will fail for this case, basically. So it fails for this case. Right? So you have to do this Inorder Traversal and then this part. Okay, so let's we can make this, we can combine this. How we can combine this is this. Should we do it here itself? Okay, let's do it here itself. Okay, so define, what was that? Or I can move to the I can move to a Jupyter notebook. Share. The problem here is then that we can't see what we had written there. Now we can see both, but okay. So what happens here is, okay, let's define the program. Where the program is. Class. Okay. So what will you do is valid BSD. You want to write in order, and then you want to write check sort. This is a little inconvenient. Okay, just to speed up the whole thing, I will be doing it like this. So first, I will be defining something called largest, right? Define init, right? So I will define a global variable, right? Largest, which is minus infinity. Now I can use np.infinity, but I have to then import np also. Import numpy as np. Okay, and then I have to do the Inorder Traversal, right? And what is Inorder Traversal? So first I will go to the left node, and then I'll go to the right node. So it means self dot is valid BSD and node dot left, right? And then self dot is valid BSD node dot right. Oh no, first left node, then the middle node, and then the right node. Okay, then now the current node, how will I process the current node? So what I will do is I will check whether my current node is smaller than largest node, or basically it should be larger than largest node, right? So I will say if node dot value is larger than self dot largest, it can be larger than or equal to. No, it should be. It should be larger. If it is not larger, then it should do something bad. It will. Now, okay. Now the question is, I should stop my algorithm as soon as I find a discrepancy, right? So it should return a false, right? It should return a false as soon as it experiences a discrepancy. And okay, this is correct. Now what do I do? But if it is correct, if the discrepancy is not there, then what should I do? I will simply say my self.largest is node.value, right? That's what we did in the algorithm. That's it. That's it. So now what we have to check is whether this one, if node.left, if this function returns a false, then what should I do? Then I should return a false, right? Because false should propagate quickly. But if it returns a true, then I should not stop here. I should continue my search, right? Very important. Please note down. If this returns a false, I should return a false immediately. But if it returns a true, then I should still continue my search. So I will say if it returns a false, which means if this is false, then I should immediately return a false. But if it returns a true, then no problem, go on. And similarly here. Is this point clear?
Yes, sir.
Yeah, this is very important that you should not stop when this returns a false, when this returns a true. But if it returns a false, then you should stop. So when it returns a false, then you end the program, return false, that's it. Okay, is this complete now? Okay, and finally, if you are able to cover all the hurdles, and then you can return a true, right? If you are able to cover all these hurdles without stucking anywhere, then you can return a true. And at each node, it will return a true. And so let's say you call this function for some subtree, then this function will return a true. And it simply means that in the parent node, this will not stop, means you don't stop, you continue. So basically it covers the entire tree without stopping if you're returning true. Now, what if you reach the leaf node, or basically you reach a none node? So you have to put a condition here. If node is none, then you return what? What should you return then? True or false? Yes? True.
Sir, true.
Yeah, because there is no problem if the node is none, that doesn't violate any conditions. So return true. Yeah, that's it. That's the simple program. Now to check the program, what I will do is I will create another cell. Okay, I can write my code straight away, but instead what I would like to do is if name, this is a very common line which you can memorize. It simply means that if you are running this program as the main program, then this will run. But if I am calling this program as a what do you call a module in some other program, for example, I want to import this function or this class in some other program, then I don't need to run these lines, right? I mean, if you don't put this line, then it will be running all those lines also. So that's what I define a root equal to the binary node. Let us call it 5. Let's use that same example, which was 53749. Okay. And then root dot left equal to bt node 3. And then root dot right equal to bt node 7. And root dot right dot left equal to what? 4, right? Bt node 4. And root dot right is bt node. I can print this tree. You can say print root. Yeah, 53749. That was, yeah. And what should be the answer? The answer should be false. Yeah, let's say I want to print. Okay, first of all, I will define the solution class. solution is solution, right? Nothing I have to give. Now print solution dot is valid BSD root, right? False. Yes. So it returned the correct answer. It should have been false and it is false. Now let's try to change it to 6. True. So the program is working for both these test cases. All right.
Yes.
Sir, can you again explain what is the meaning of if name equal mean?
Acha, this line, this is just to say, okay, so in Python, what you can do is you need not write the entire code in one Python file, right?
Okay.
You can also write certain classes and certain functions in some file and certain classes in some other file, certain classes in some other file. And then there is one main code which will be running and which will be importing those classes from the other files.
Okay.
Right? Classes or functions, whatever. So let's say the name of the program, let's say is 07 practice. Today is 7th class, so 7.7 practice. Now what I can do is if I save it as a Python file, .py file, so you can import as a, right? You can say download as a .py Python file. Then I can import this file in some other notebook or in some other Python script saying that import 07 underscore practice, just like you are doing import numpy. You can do import 07, it means not here, but in some other 07 practice. Okay, it cannot have a number in the beginning. Let's say A07 practice. If I name it as A. Import A07 practice. And then you can use all those classes. I can say sol equal to A07 underscore practice dot solution. So all the classes and all the functions will be available within this name or the module which you have imported.
Okay.
Right. And the thing is, when you are importing this module or this file, then what happens is it will be executing this whole file because all these classes and functions will come in the RAM of my program basically, right? So therefore, if I don't put this command, then all these variables will also be stored. Yeah, and they will also be run. So for example, here you are running the code, then the whole code will start running. It will waste your time, it will waste your memory. But rather if you put this, then what happens when you import this as a module or as a library from some other program, then these commands won't be run. Only these classes will be imported.
Okay.
And this code will not be executed. Okay, so thank you. This is important because when we do automatic assessment in this course, we are importing your file as a module and putting it in our evaluation script. So if you don't comment this out, then these commands will be run, and if your program takes a lot of time, then it means we will face problems at our end, and we have some hard limit on execution time, so your code will not be run and you won't get marks. Then we have to manually correct it. It will be a waste of time essentially. Okay. Yeah. Is that clear? Anybody has any doubts? So what we have done essentially here is we have merged the Inorder Traversal with the check assert or check ascending function, right? Okay. Let's go to the next problem. I would like you to solve this problem. Actually, this problem was asked by some of you. This is the question. Now, given a BSD, you have to create another BSD which is balanced. You know what is a balanced BSD, right? Balanced BSD is basically when you don't have any, or basically all the levels are completely filled and only the last level may be unfilled. only the last level may be unfilled. Now, in that unfilled level, the nodes can be on the left or right, anywhere, doesn't matter. In complete BSD, they must be on the left, but in a balanced BSD, they can be anywhere. So that's what you have to do now. Given a BSD, let's say if I give you this BSD, first tell me, is this balanced or not? Is this BSD balanced or not?
Yes, sir. Balanced.
Yeah, it is already balanced. Yes, it is already balanced because the last level is unfilled and before that all levels are filled. But if I change it to, let's say, root dot right dot left is BT node 8. Yeah, so it is still a valid BSD, but just that it is not balanced anymore. So can you generate a balanced BSD? That's the question. How will you do that? I'll go back to my board. Yeah. Yes. This is the question. So given a BSD, you have to balance it. This is an example. Oh, doesn't print properly. Yeah, so what will you do? Given a BSD, you have to create a balanced BSD which is balanced. I'm not asking you to verify whether it is a BSD or not, given that it is a BSD. It's already validated. And you don't know whether it is balanced or not. But you have to create a balanced BSD. How will you do that?
So we have to add elements like.
You don't have to add elements. You have to restructure the BSD. For example, okay, let me.
Sir, we can like traverse the in order the whole tree. Then we can take the middle element as root, and then we can start adding the element into the tree, like mid -1 to the left and mid +1 to the right, like that.
Yeah, good idea. Yes. So this is our tree. Here we have 6. This is the tree, and when you do the balancing, then this may become this 8 has to go somewhere. It could be 6, let's say 6 here. Oh, 7 should be here. It can come here and it can come. Right, this is a balanced BSD. There could be other combinations also possible, but this is one of the possible answers. And you can return, if there are more than one answer, return any one of them. So this is one of the valid answers. Okay. Yeah, so I think you already mentioned that you are given a BSD. What will you do? First, you do Inorder Traversal, right?
Yeah.
To get what? To get an array.
Array.
Or basically a list. And then
Take the middle element as new root.
Basically convert the array to a tree.
Yeah.
To a complete or to a balanced BSD. Okay, good. This looks like a good algorithm. So what is Inorder Traversal? That we already have written. This is Inorder Traversal, right? And you are actually using an array. So you are saving it in the array. Okay. Let's now look at the other algorithm. How do we convert the array to a balanced BSD? So given an array A, so let me say define. So what function should I define?
Array to BST.
Array to BST, okay. What should be the inputs? What should be the output?
Input should be an array.
Input should be an array. Okay, ARR, let's say.
Output
What
should
else?
be BST.
Output should be a node, okay.
Okay, root node.
The BT node is okay. Then
Uh, uh, let's say n is equal to length of array. Then we can assign the middle element as root.
should we do it like this, that all of you can try to solve it in your machines, and so that everybody gets a chance to kind of brainstorm or to go through the problem, right? Why don't you solve it on your machine and then return me with the final solution? But the logic is correct, that use this first Inorder Traversal to get an array which will be sorted, you know that. And then you convert this array to a balanced Bsd, right? So do it in your machine and let me know the answer. You have 5 minutes. Is that sufficient time? If you need any help, let me know. If you're stuck somewhere, let me know. All of you have your Jupyter notebooks with you?
Yes, sir.
Thanks. Okay, done. Is that done? Is it done? Anybody?
No, sir.
Not yet, sir.
How much more time do you need? Five more minutes? Yes, is that done? Could you do it? Should we start doing it together? Okay, so here we are. We are given a tree and we have to balance that tree. So how should we start? Let me first write down the basic commands. So I'll say here, first of all, import the binary tree node as a BT node. And then I will, this is given to me. Right. Input is a BT node and output is a BT node. So basically somebody gives me the root node and from the root node, I can access the entire tree. And then I should return a root node, which is the root node of a balanced BSD. And that can be used to access the entire balanced BSD. Right. So what I will do is, first of all, as you know, I have to define a list, right? A list A. Let me initialize it as a blank. Now, okay, there are two ways. I can either define a self.a, right? But should I solve it, or I would like to invite some of you to solve. Who has already solved the problem?
Sir, I thought of an algorithm, but actually in my Jupyter notebook, binary tree is not there, so it's not running. So what I think thought of,
Okay,
like,
so no problem. You can define a node like this. Just a minute. You can define a binary node on your own like this. Class BT node. Right? You can also define it like this. Simply, it has self.value, self.left, self.right. That's it.
but I won't be able to print the tree.
Yeah,
right?
you won't be able to print it there. Yes. Then you have to import the, sorry, you have to install the binary tree, this pip install binary tree.
That is what I'm running right now.
Okay, so there are various ways. One of the ways is that you define every class inside this, sorry, every function inside this class. Or another way is you can define nested classes. So what is a nested class? Means class inside the class. So basically I can define, nested functions, function inside a function. So I already have this function, which is the main function which I have to call. Inside this, I can define other functions. So I can say, I have to do two steps here first. One is the Inorder Traversal, which will make the list. Let me write it down. So number one is the Inorder Traversal to get A. And then number two is I have to do now what? From A, I have to build a balanced BSD. So build a BSD from A, right? So let's do the Inorder Traversal. I think this is a very simple function. I will say if, what do you say? Define Inorder Traversal. And what am I given? I am given a node. And that's it. I'm using a global variable, this A. You can also pass the A inside this, but anyways, I'm keeping it like this. And now, first of all, you will say if node is none, or you can, another way to put it is if not node, basically, which means if node is none. then you return. Don't do anything. But otherwise, what you will do is, first of all, you will do Inorder traversal of the node. Inorder traversal of node.left. And then you process the current node, which means you will say a dot append node dot value, right? And then you will say node dot write, right? That's it. Then return. That's it. So this is the Inorder traversal of, and what will it give you finally? It will fill up your A. So a very good verification here will be just print the value of A. Okay, let's try to run it to see whether my traversal is doing properly or not. I have to, okay, let's use the same function. And here I will say Balanced Bsd. The function name is changed now. Balanced Bsd of root. Oh, it did not print the right thing. It is not doing what it is supposed to do. Why is it not doing? It's not printing A correctly. Okay, why is it not doing? Because I have not called this function. Okay, so I'm sorry, my mistake. I should call this function, no? I've defined the nested function, but I never called it. I have to call it with the root node. Yeah, now it is printing. It's printing multiple times because I have put this extra print statement. Yeah, so it is printing 3, 5, 6, 7, 8, 9. So it's printing in the right order. Now I have to write another function. So this printing can be turned off. Now I have to write a function which will build the BSD from A. So I have to define a function. Let's call it as build a balanced BSD, right? And what is the input? Input is my A, or anyways, A is a global variable. A is also visible here, so I don't have to call it. But what it should do, okay, so the strategy is like this. Okay, anybody would like to suggest what strategy should be used to build a BSD from a list? I think this you can suggest. I should not write it. Yeah. How will you write the second function?
Sir, what I thought of, like, we will first declare the middle element of the list as root node, and then we'll divide the whole array in two parts, excluding the middle element, left part and right part. And again, recursively, we will call this function on left part and right part, and we'll do like that.
Let's say you will say my let's say the index of the mid element, indices are 0, 1, 2, 3, 4, 5. The index of the middle element is what?
2.
2. Let's say the length of A divided by 2, and you convert this into an int, right?
Yes.
Length is 6 over, this will point to 3. Length is 6, 6 upon 2 is 3. So the middle element is 3 here in this case. Okay, anyways, both are middle. Okay, then what will you do?
Add left equal
Pardon?
add left. First I'll like declare that root equals BT node of I mid.
Okay.
Root
Okay.
or any node I can say.
Okay, define array to BSD. Let's say here I define IMID equal to int of the array A, array, comma, sorry, divide by 2.
Lane of array.
Yeah, length of array divide by 2. Then
Root node equals for any
root.
node.
Okay. Pardon?
Just node equals
Node equals. Node is
BT node add I mid.
Basically, okay, array I mid.
Now,
okay.
Now add left equals
Add left is
add 0 to I mid
0 to I mid,
and then add right equals I mid plus 1 to up to end.
Okay.
And then node dot left equals this node dot left equals add to BSD add left
right?
Yeah, and node dot right equals add to BSD add right. And then I need to put one termination condition. Like if a length of add left is only 2, then it should stop, or 1, then it should stop.
Pardon?
Like length of add left is 2, then it should stop. I've not put the termination condition, so that's
So what should be the condition if array dot left, sorry, array left dot length of array left is what?
2, then it should terminate.
Why?
But if there are only 2 elements, then
okay, but this will return node, right? Why should it terminate?
if only 2 nodes are there, then.
But how will you put those 2 nodes? Means you will not put those 2 nodes in your array then? Means into your tree then? You want to put those 2 nodes in your tree also, right?
Yeah. Okay, then if array is none, then that should terminate.
So yeah, you can put here, right? If length of array is 0 or something. Then return none, basically. Right?
Yeah, else this should.
Okay. Everybody agrees with this?
हम तुम्हारा टिकट ले.
Pardon? Is that agreeable to everybody? Let us code it. I will quickly write it down in my
बगल कहीं ऊपर नीचे या बगल बगल सामने.
Okay, define balance BSD, and here you are giving an array as an input, and you're saying, and this will return some node.
मिल जाता है प्लीज, मम्मी पापा सब एक साथ ही मिलता है.
Length of
साथ ले लेंगे.
then return And otherwise, you're saying imid equals int of length of array divided by 2. That's it. Yeah. And node is node. Okay. Imid array left equal to array Yeah, this is a clever algorithm. I hope it should work. That's it, right? Return mode. Okay, and now you have to run this algorithm. You will say return balanced Bsd A, right? Okay, let's see what does it return. Yeah, it returns a good answer. 3, 5, 6, 7, 8, 9. Yeah, it's a balanced Bsd. It works perfectly. Yeah, well done. Okay. Is that clear to everybody?
Yes, sir.
Okay, can you improve this algorithm? Can you improve this algorithm somehow? One improvement could be like you are passing the whole array into your function. Instead of array, so basically when you're passing the array, then in every stack you are defining the arrays. So what will be the complexity of the algorithm? It will be of the order of the memory complexity, not the space, not the runtime complex, not the time complexity, but the memory requirements will be of the order of. This is there is an array of length 10. So you'll be saving the array of length 10, and then you will be saving the 2 arrays of length 5. And then within the next stack, you'll be saving 2 arrays of length 2 and 3. Okay, 2 and 2 and 2 and 2. So basically, your memory requirements will be how much?
N factorial.
Almost n square, right?
N square.
Yeah, almost n square of that order. Memory requirements are quite high. But instead of passing the whole array, if you can just pass the start index and the end index, and we already know the array, this is the global array available to us, right? On this global array, if we just pass the start index and end index, then it should be done, right? Like instead of saying array left is this, I can simply say the the start index of the array left is 0 and the end index is imid or imid, imid or imid -1, because I want to just send the exact index, not the +1 thing. Then you can make it memory efficient. Anyway, this was just a small point, but these points become important when your algorithms become large and they scale up. So how can you reduce or minimize the memory requirement and the space requirement? Okay, so is that all right? Do you have any questions here?
Sir,
Yes.
sir, can you explain the very first line from binary tree import node as BT node? So why we use this syntax?
Okay. As I told you that you can define a class called BT node, and in that class you can define variables as value, left node, right node, right?
Yes, sir.
That should be sufficient, but then it won't print this tree like this, right?
Okay.
So for that, you will have to write another function on your own. So to save time and to save effort, I just imported this binary tree class from some library, which you have to install separately. And then it will just print this tree nicely so that you can quickly verify your answers.
Sir, actually, I wrote this command on my Google Colab, so it is not running. It is printing that you should manually install dependency using.
Okay, if you are using Google Colab, then you can run a command like this. So you can say here, means in the beginning, you have to say, to install any library, you will be using this. Means you started with an exclamation sign, then say pip install binary tree. Oh, I don't remember the name of the library, but I think it's by binary tree.
Yes, it is correct.
Right, pip install binary tree, and when you put an exclamation sign, then Google Colab will run this command as a Linux command, not as a Python command, as a kind of terminal command, which you run on your Linux or Mac terminal.
Okay, sir.
Okay.
Thank you, sir.
Thank you. Okay, thank you very much, everybody. So complete your assignment by Sunday evening. So that the deadline is shifted by 2 days, which means instead of Friday evening, it is Sunday evening, same time. And you will be soon receiving the next assignment. I'm thinking in this course, we can do assignments. Let me first stop the live streaming.